Is your house a smart home that lets you monitor and control everything remotely? If it is, you're way ahead of me, because I can't control anything but the thermostat in mine, and I don't actually care. But I am trying to add some energy and temperature monitoring features to my 47-year-old house, and this is the third installment of that adventure. Stick around and see what can go wrong this time. Hi, I'm Gary. I'm a retired engineer, and I make videos about technology subjects that interest me as an actual user. I try not to get too drowned in technical details, although once in a while I step in a puddle that's deeper than it looked. This is the third video in a series about my attempts to monitor the power and energy use of my fairly new heating and air conditioning system, along with temperatures in various locations inside and outside my house. My aim in doing this is to see how the system is working and whether there are any obvious changes I might make to improve either the energy efficiency or the comfort level of the house. But I have to confess, a lot of my motivation is also just having fun learning some new technical stuff. And boy, did I bite off a big chunk of that, because everything in this project has been a runaway learning experience. If you saw the previous video, you already know that I managed to get all my sensors working and reading out values to a computer. In total, that's 2 power monitor modules that measure voltage, current, power, and cumulative energy use separately for the heating and the air conditioning, as well as 5 temperature sensors, 2 outside and 3 inside my house. I did finally receive the little plastic enclosures I ordered for the indoor temperature sensors, so they no longer look like a junior high science project hanging out of the walls. After that, the next theme that seemed desirable was some way to display the measurements, in hopes of not needing to have a computer permanently attached. The sensors are already connected to an Arduino Uno microcontroller that reads the data. Actually, it's a clone. Once you get a program running on it, it doesn't need the computer anymore. You just have to supply power to the board, and it'll sit there measuring away all day long. But there isn't much to see while it's doing it. So I bought a 4-line by 20 character LCD display that could interface to the Arduino on its so-called I2C bus, which I'm not going to talk about, using only 4 wires. I hooked it up, and amazingly it worked the first time. It required some abbreviating and rounding off values, but it's able to display the power and energy readings from both power monitors and all 5 temperatures with labels. Pretty impressive for something that cost $2 at the time. The next stage of the plan was to be able to record and eventually analyze the data coming from these sensors, instead of just looking at them on a computer screen. That started out promising to be fairly easy, at least the recording part. I simply purchased a data logger shield for it from AliExpress. Shield is Arduino speak for a board like this that plugs into an Arduino with pins that connect directly to the terminals on the microcontroller itself. This one is equipped with a real-time clock chip and an SD memory card slot, just like the ones used in digital cameras. In theory, all I needed to do was add the software to read the date and time from the clock and write the sensor readings along with the time to an SD card. Then the recording part of my project would be done. I found some software examples of how to do those 2 things and tried them out, and they worked fine individually. I managed to save an hours-long file to the SD card, recording values 10 times a minute. More than 10,000 readings, and I could also read the date and time from the real-time clock. Not at the same time, but still a good start. My original software sketch, which is what the Arduino world calls a program, was pretty messy at this point, so I rewrote the whole thing from the ground up and added the clock and SD card features to it. I'm new to C programming, so it took several hours of debugging to find all my errors and chase down all the bugs involving capitalization, brackets, and function calls. But eventually it compiled without errors, and it only used 70-something% of the available memory. So I thought I was home free. That's when disaster struck. The program ran, but it produced absolute garbage for output. What was worse, it did some things that should have been impossible. The setup loop, for example, which only runs one time when the program starts, kept running over and over again. That can't happen, can it? As a novice Arduino guy, I assumed my program was doing something wrong and spent hours trying to troubleshoot it, putting in print statements everywhere and messing around with pages and pages of program listings. All that gave me was a headache. Eventually I did the sensible thing, which was a Google search on this behavior. That's when I discovered the hidden gotcha of the Arduino Uno, which is a very low-end microcontroller. If you saw my earlier videos, I mentioned comments suggesting I use a more powerful microcontroller. What I said in response was that it seemed to be doing the job so far. I'm only interested in reading my sensors every few seconds at most, so it takes very little computing power. However, there's more to computers than processing power. The problem turned out to be memory. Yeah, I have a memory problem too, but it's only because I'm old and my brain is tired. I'll make this short and simple, but you need to know this if you ever intend to use an Arduino Uno or one of its siblings for anything. The Uno has 32 kilobytes of flash memory for program storage. It's pretty much the kind used in memory sticks. That's enough to hold quite a substantial program, as it turns out. I didn't come anywhere near using it up. But, and this is a big but, it has only 2 kilobytes of static RAM. If that doesn't tell you anything, it's roughly 1,000,000 times less than a low-end smartphone has. Arduino sketches use that to store the information that might need to change while the program's running. Some kinds of data are stored in an area called the heap, and other kinds are stored in the stack. Here's a great diagram of how this works that even I can understand from an excellent article by Bill Earl that's referenced in the description. These two chunks of memory share that minuscule 2 kilobytes, and they grow toward each other as the program runs and does things. Guess what happens when they overlap? Yeah, you guessed it. It either crashes or does what mine did. It turns out that the culprit is almost certainly the SD card reader, because it reserves a big chunk of all this memory for a buffer when the program starts. To add insult to injury, the data logger shield apparently suffered a failure while I was trying to diagnose the problem, because I was never able to read the time or write to the SD card again, even with the simple examples that worked before. That approach was clearly dead in the water, so to speak. At this point, I need to confess that I'm leaving on a 6-week vacation next week, starting with the upcoming eclipse. I really wanted to get this next video done before then, so I'd have something to show for all this effort. That meant I needed a plan B. Fixing the timekeeping part of the problem was easy. I bought this DS3231 real-time clock module from Amazon, 2 for $7 with 2-day delivery. It connects to the Arduino over that same I2C bus the display uses. It has a coin cell battery for months of power loss backup, and it has higher accuracy than the one on the data logger shield. It's made for a rechargeable battery, so if you use an unrechargeable one like I had available, you need to remove the charge resistor so it doesn't overheat and explode. That's easy as long as you can unsolder something 5 millimeters long without a microscope. In the long run, I expect to solve the data logging problem by using some other SD card module, probably one on a separate microcontroller linked to the data gathering one. But in the meantime, I wanted to at least see some data getting saved and maybe graphed before leaving on vacation. Which brings me to a quick and dirty solution that's available for free, namely a piece of data logging software called PLX-DAQ. It's actually a macro that runs in a special Excel spreadsheet and communicates with the Arduino over its USB serial port, which is the same way the Arduino development environment allowed me to see my sensor readings. To use it, you just have to put the keyword data in front of a comma-separated string of your sensor values and then print them to the serial port. PLX-DAQ grabs the serial port, reads the data, and copies it into columns in the spreadsheet. From there, you can construct graphs or save it to a file as you desire. It has some limitations. If you move things around at the wrong time, it crashes. And I haven't figured out yet how to make a graph that's a window into the most recent data, or how to get them to display the time. But here's a sample of it taking data in and then graphing some of my measurements in real time. It definitely reinforces my feeling that graphs are the best way to look at data like this. For example, I hadn't noticed until I graphed it that the outdoor temperature measurement seems a bit jumpy sometimes. I don't yet know if that's real or something glitching in the data acquisition. I know there's some funny things happening with timing, so I may still have some measurement issues to work out. But for now, it works. Its biggest limitation, of course, is that it requires a full-time connection to a computer running Microsoft Excel, which is the very thing I hope to avoid. But I have several older computers lying around, waiting for some job they can still perform, so it's no great hardship for the moment. That's it for this video. I'm sorry the project isn't progressing as fast as I hoped, but the real world's like that. Stuff happens, and the best-laid plans go awry. Not that this was one of the best-laid plans. I warned you about that in the previous videos. I hope you enjoyed the video, and if you did, a like would be appreciated. Feel free to subscribe to the channel. And if you're kind enough to push the notification bell, I promise there'll be more progress to come. It's just going to take a while. In the meantime, as always, thank you for watching.